So yeah, we will discuss CI at an AI conference. So I don't know if you're there because you love CI or because you hate CI, but both are fine. But yeah, joking aside, I mean, we are AI engineer. I mean, CI is one of the main good practice, of software engineering. So it's not because we have AI that we need to not focus on CI. So yeah, very quick introduction. As I said, I was working at Docker. I'm a Docker captain. I'm working at Dagger. One fun thing is Dagger has been funded by Docker's creators. It's still in the same loop. And yeah, basically playing with containers and developer tools for, I don't know, 8-9 years, something like that. If you don't know yet Dagger, let's say we're reinventing the CI. We're not trying to fix it or to improve it. We're trying to find another way to do CI and to do that way better. But you'll probably understand that a bit later in the talk. And to go straight to the main point, if you're using AI agents, you're really changing a bit. You're more and more just an integrator. Anything like if you're using, it can be AI coding agent, it can be bots, it can be agents, anything. But then you're just an integrator. But what that means exactly, just to be sure everybody is on the same page, why I'm just becoming more and more an integrator. Basically, the integration means you want to check your changes against policies, rules, and conventions to run tests, unit tests, integration tests, etc. But ultimately, what you want is to have a point where you can make a decision. Can I add those changes to my mainline, to my product, and be able to ship them, deploy them safely and confidently? That's the main thing. And yeah, if that's your code, you're just an integrator. At some point, you need to decide, yeah, I want this stuff. If it's someone else, like when you develop like classical way or legacy way, if you want code, you're just an integrator. But if it's an agent, this is the same thing. And it's more and more. And one of the issues is sometimes you're just completely blind with smart agents. So let's take a small example. To prepare this talk, I just asked Cloud Code, to build me an app. It's just a clone of 2048 game in Go in CLI. So, it was kind of easy. The result, just working. That's fine. So let's say this is the starting point of my story. I have this stuff, and then I ask Cloud Code to do a small change. Just, can you make me a banner that is better, like with colorful, with more colors, etc. That should be an easy task. It's just printing some lines on my CLI. So I did that. I just run Cloud Code, but it can work with any other tools. And then the first issue is it was just blocking me. Like I was waiting for Cloud to do something. I was stuck behind my computer because the agent is working on my machine, on my branch, on my file. So if I want to change something at the same time, I just stuck there. And sometimes it also asks me for stupid questions. Like, do you really want to run something or to validate some changes? So I was just waiting. Sometimes I will just go something else. And when I go back, it's just waiting for an input for 30 minutes. That's why at Dagger we built something that is called container use. Basically, this is sandboxes for AI agents. So it will allow the agent to work in full isolation using containers, of course. And you don't have to wait in front of them. They just work on their own branch, and they're fully isolated. So the thing is, you can have one, but you can have also multiple ones. So you can do something and at the same time have one or multiple agents working on the same code base on your own machine. Maybe some will, improve your documentation. Some will do some refactoring. Another one, some features. You don't care. They're just all in parallel. And they don't ask you stupid questions. They just work, and then you can review what they did and start to work with that. But that's one of the issues. At the end, I just have a lot of branches on my machine. all generated by AI, and I need to decide what I want to do with that. Are they good enough? The test passing? All that stuff. One way is I can just push all those branches on CI. I mean, I already have like my GitHub action, for instance, configured on my repository. That's fine. But do you really want to spend your days reviewing all random pull requests, I mean, generated by AI? I'm not entirely sure. How many will be irrelevant? Maybe some of them need some adjustment, maybe sometimes really small, but you're just increasing the feedback loop because you're pushing something that will run the full stack, and then, oh yeah, I just forgot to mention something to the agent, so I have to go back and start again and again. And it also costs a lot of money because all those branches, I mean, especially sometimes, I mean, like when you want to redirect the agent, you will just change your prompt and start again from scratch. But you just spend your full time on your CI just to realize that this is not good enough. So at least this is probably just my opinion, but we should always start the integration directly on the developer's machine, always. And by that, it also means with the exact same tool that are running remotely. If we're not using the same tools, we're just adding chaos to chaos. We will enter again the it works on my machine, but not on the CI. Or one other question is, why can't I run the exact same test than my CI, or how to debug my CI? I mean, sometimes if you look at the history of commits on repository, that's always fun when you see, oh, fixing CI. Most of the time, like 5 minutes later, fixing CI for real, or fixing CI again, because you can't debug that stuff, because you can't run the same tools on your machine. So let's just go back to my 2048 game and see what we have. So I asked Claude, no container use, nothing, just very plain code, basic. Can you just improve my banner? And he asked me this stuff, hey, are you happy with this change? I mean, that's great, but I mean, I can't say nothing about that. I mean, this change is completely irrelevant. And it just asks me, and it waits for me to answer that question. But I can understand this change, but what's beyond the display banner? I have absolutely no idea, and I have no way to test this stuff. So yeah, at some point I just say, okay, yes. I will not say the second one, like yes, always, because I have no idea what comes next. So yeah, I mean, that's still a pretty simple task. I mean, I just improve the banner. And that's the result. I mean, that's a real example. I really did that, and just create me this 3048. And that doesn't make sense at all. It was really a simple task, but no. So I try like the third one. Like, no, this stuff is kind of ugly. Can you just write 2048 and not 3048? And it did. It wrote 2048 on top of my 3048. So at some point I just gave up. And this is like the final result. Yeah, that was a pretty good experience. But yeah, I mean, this one is a basic example. It's a basic one, and it's very easy because it's visual. I can easily spot the issue, but when it's about code, when you have hundreds or thousands of lines of code, you can't just check that way. This just become a pain because, I mean, especially if it's on your machine, so when you want to decide, okay, should I push that to my repository to have my full CI working and to put that on review? I can't know. It's impossible to know if that's good or not. And if I go back to the first change, the only thing I can say is just, I mean, I can do it just to pray. Like, yeah, that looks fine, but I have no way to do that because we need integration tools everywhere. I can run, but also that the coding agent will run the exact same one. And that's what we are doing with Dagger. So Dagger is open source. So we say it's runtime for composable workflows. That sounds like a bit generic, and yes, it is generic. But the main thing is we're providing high-level components. A lot of pipelines, a lot of workflows are just made of make files and bash files and all that stuff. And if you want to deal with Git, you will use the Git command line. If you want to deal with containers, you will just run, I don't know, Docker, CLI, whatever. In this case, we have objects. We have types object with function, and we have high-level primitives. So a container is a real one. It's not just about files or CLIs. We have repositories and directories and all that stuff. We have also a way to rapidly prototype stuff. We have kind of Dagger shell. And this stuff can look like the file, but you're fully interactive. So you can say, OK, I have my container from Alpine. I want to add this, run this command, add this file, etc., and give me a terminal at the end. Or push that to a registry, whatever. You can experiment all time. And one of the main components we have right now is also an LLM. So we can integrate LLM inside agents. So again, this is high-level primitive, so with object and functions. And we can, for instance, give a container to the LLM and say, OK, you have this container. Maybe it's the container you build with your own application inside. And you will prompt your model, OK, can you do this stuff or install this stuff inside, etc. And it can give you back files or directories or repositories or even a container. So you can have your model working inside and then push the result to a registry or whatever you want. We have multiple SDKs on top of that. So the three main ones, are Go, Python, and TypeScript. I'm maintaining the Java one. There's some people working on PHP, on .NET, Elixir, Rust, and it's fully interoperable. So one of the main cases is like you have, a platform team working in Go or in Python, creating some building blocks because, they decided the way to build like the image. And maybe your team, your application team is working in TypeScript, but they will be able to use from TypeScript the components made in Go and the other way around. There's no problem at all. So just to give an example, this is the part of the file I built, I created, for this experiment. And at the bottom, we can see this is the function to create an image. So it's very close to the file. So I just have my container from Alpine with my workdir, and I have a file. And this file, in fact, is coming from another function where I'm go build my application. So it's like a multi-stage build, but in code. And if we look at the one in the middle, it's just my Go test. So I just run Go test, always inside container. Everything is running inside container always. It's all immutable. I just have my build-off. Build-off I just didn't show on the screen because that was just a bit too big, but that's where I'm just putting my code and the libraries and all that stuff. So I wrote this file once. And then I can go to my terminal and just type dagger call test, and that will run my test inside my container. But I can also write a YAML file that will be by GitHub action, and I will just call test. And on GitHub action, I will just have my test. And from there, we start to have something interesting is we have observability at all time. So whatever it's running on like my CI or even from my local machine, I can see the traces of everything that has been run by Dagger. So I have at the bottom my test function. So this is the exact same one. But I can also expand it. So I have my Go test at the bottom, but I have all the different steps to understand how has been built the container in which I will run my command. And if I have some kind of multi-stage build, I can also just go back and say, OK, this binary is coming from this container, done that way, etc., etc. So I can debug CI. I can debug the tools on my machine also. I have full observability. And obviously, there's more. That is, I have also Dagger MCP command. So we saw inside Dagger, I can have the LLM object, but I have also this MCP command. So all those functions, the one I showed you before, are exposed through an MCP server. And so my agent, I can just explain to it, like, OK, use all the tools you have, and only this one. Do not run anything on my machine. And my agent will, for instance, to test changes, will run the exact same code as the one I'm running by hand or on my CI. So at the end, the thing is I have one single definition that works on my machine, on my remote CI server, on my coding agent. And the main thing behind that is we have to build new integration tools for today's challenges and not the one from the past. I mean, AI is not changing everything. I mean, the question of integration already existed before. But with AI, we just have a lot of more code generated at some point somewhere. And we have to integrate that as soon, at least, you want to integrate that in your mainline and build real product and not just experiment. So it's full open source. You can join us on dagger on GitHub. There's also a Discord. The full company is on Discord, so you can just go and chat with us on that. And I think at the end, I was just a bit faster than expected. But yeah, but thanks for your attention.